Welcome to the session. As we see already one video clips about that general normal function of that thermal power plant, which states that different systems involved under basic operation. Now we are moving to next level. What are the main components in associated with the thermal power plant? See the picture. This is the different equipments with the numbering. You can very easily see that this is a cooling tower, this is the transmission tower for electrical, this is a generator, this is a turbine, and like this is the electrostatic precipitator, this is a furnace, this is the boiler, preheater, economizer, and superheater. Like this we can see the stack. So these are the numbering with the different equipments. By seeing this picture you will come to know the specialized organization of the equipments and different systems involved in this plant. So these equipments which is arranged in that is segregated in 5 stages. The first stage covering the coal conveyor, coal hopper, pulverizer mill, and ash hopper. So these are the equipments coming under the system of coal handling system and ash handling system. The second stage we can use to tell the steam generating plant is the boiler. So boiler drum, superheater, reheater, economizer, preheater, forced draft fan, induced draft fan, and the chimney. These all coming under the stage 2 of your steam generating plant called as a boiler. Then the stage 3 and 4 is that steam turbine and alternator generator, the pressure turbines and steam governor, boiler feed pump, deaerator and generator, transformer and tower. Tower is a transmission tower. These and all coming to the stage 3 and 4. The last stage is coming the feed water cooling system, cooling tower, water pump, condenser and precipitator. So these are the components the marked here and giving this name of the equipments in this diagram. So each equipments are involved in the each systems. Accordingly this numbering takes place. So in this, out of all the components we will choose the very main important equipments. Then we'll discuss what is the equipment, why this equipment is provided, what is the purpose, and how efficiently it will work. Those things and all we are going to see the next session. So the first thing is the whole handling system, the coal pulverizer. Coal pulverizer is very important because when the raw coal is a solid particle, uneven coal we can't straight away feed it to the furnace to get fired because it will not get complete burn. In order to get complete combustion, it is necessary to make the raw coal into the powder form by means of in the coal pulverizer. See here the left hand side, this is a typical coal pulverizer in one of the thermal power plant. This is the inside arrangement. There is a ball on the traces. So the coal is getting feeded inside the drum. So inside there is a several rotating mills are there. That is a two traces and ball rollers. So in that the coal is feeding and getting crushed into the fine powder, and finally it is going to feed to the furnace. So pulverized coal firing ensures complete combustion of the coal, thus ensuring higher efficiency of steam generators. It is predominantly adopted in large coal-fired utility boilers. If you see the large capacity thermal power stations, large power plant, this type of pulverized mill, we used to call pulverized mill or pulverizer, or tube mill or ball mill we used to kill. It is there in the coal handling system. The heart of pulverized coal-fired boiler is the pulverizer, also known as the ball mill or tube mill. Also that pulverizer we used to call ball mill or tube mill. Why? Because we are using inside ball and traces mechanism to crush the coal into powder form. So the pieces of coal are crushed between the balls and cylindrical rollers that pulverize, that move between the two tracks or races. The raw coal is then fed into the pulverizer along with the air heater to about 330 degrees centigrade from the boiler. So once this coal is getting pulverized into the powder form, then there is a external air, which is preheated external air is supplying inside the pulverizer to push the pulverized powder form coal and feeding to the furnace combustor area. So the powdered coal from the pulverizer is directly blown to the burner in the boiler. So the pulverizers can be classified according to the speed of operation. The slow speed mills, ball tube mills are used, and the medium speed mills, that is used bowl, ball and race and roller mills, and that are used for the coals ranging from sub-bituminous and anthracite type of coals. The bituminous and anthracite type of coals we are using slow speed and medium speed mills, and the high speed mills are generally used for that lignite coals. To crush the lignite coals, we are using that high speed mills. So this is the coal pulverizer, as I discussed already. Inside the coal, this is a overall coal pulverizer. Inside that pulverizer there is a ball and traces. The coal is getting fed and crushing in between, so that's outlet will be the powdered form of the coal. So this is the one of the hot equipment in the coal handling unit. When in coming to the ash handling system, the ash is getting collected bottom of the furnace by means of bottom collector. In addition to this, there is another ash, that is a fly ash, which is flow along the flue gases inside the furnace, that going to be recovered by means of using some electrostatic precipitator, which is working on the principle of electrostatic operation. So the picture here that shows the top side, this is a practical electrostatic precipitator. So the flue gas is entering here, flue gas is out. So in between the fly ash getting catched by this precipitator. So what is precipitator? We are going to discuss now. An electrostatic precipitator is widely used as a pollution control device in thermal power plant. It removes the fine particles like dust and smoke from the exhaust flue gases using the high voltage electrostatic charge. See here the picture, this is a electrostatic inside arrangement. There is a plates and there is a rods. These are the positive and negative elements. This is a positive and negative elements which are connected to the high voltage power supply, DC power supply. Because of this high voltage, these plates become positive charged and it's become negative charge. The positive charged plates attracts the negative charged ash particles, and the negative charged rods attracts the positive charged ash particles. Both ash particles are getting collected in the collecting plate, and finally it is disposed to the ash storage area. So this is the basic working principle. This is working and based on that electrostatic principle. So when we are giving the high voltage supply, this positive and negative plates are attracting the positive and negative based ash particles and is getting collected. That is a basic phenomena of operation in that. So that unburned particles of the carbon are pulled out of the smoke by using this static electricity in the precipitators. So the leaving clean and hot air to the escape the stacks. So that is the main purpose of this electrostatic precipitator. So when coming to the boiler side, in generally the boiler we can classify two types of boiler, that is a fire tube boiler and a water tube boiler. So the boiler is a closed vessel together with the furnace in which high pressure steam is generated. According to the flow of hot flue gases and water in the boiler, it can be classified into two types. See here the fire tube boiler, the water is circulated surrounding this shell area and the fire is going to be in the tube. This is called fire tube because this fire flue gas is flowing through the tubes. That's why we call fire tube boiler. And water tube boiler is that water is circulating in the tubes and the fire is surrounding, the flue gas is surrounding the tubes. That is called water tube boiler. The water circulates through the large number of tubes and the hot gases passes around them. According to the axis of boiler shell, it is going to be vertical and horizontal. According to the position or location of the furnace, is internally fired or externally fired. According to the pressure vessel, operating pressure, that is going to be low pressure, medium pressure or high pressure boiler, and according to the application, it is stationary or mobile application. Mostly these water tube boilers are used for the thermal power station for the large scale applications. So these are the boiler. This is the basic types classified according to the flow of water and the flue gas in the boiler. The next one is that associate elements involved in the boiler plant, that is called boiler drum. The boiler drum is a reservoir or the hot water and steam mixer at the top end of the water tubes, and it acts as a pressure vessel used to separate the steam and the water mixer. See, this is the boiler drum, the blue color one. In this, there will be the water and the steam mixer will be there. Once is getting water is boiled, the steam is coming out along with the moisture vapor. There is a inside cyclone separator. That separator separates that moisture particle and push down this moisture particle, and only the steam vapor is going to be out to the steam header. So this is the basic function of the boiler drum. Also it is holding the reserving the water and steam mixer in that. The next one is that it has the blow down facility to reduce the dissolved solid contents of the steam. When you are operating for the long time, there will be the bottom of the boiler drum, there will be the sediments depositing in the boiler drum. You have to remove time to time by means of through operating some drain valve, blow down valve. By opening this valve, we are pushing the steam so that whatever the sediments, it will be carried out and discharged to the outside. This operation going to be done routinely according to the water chemistry, water quality. So this is the boiler have the facility of blow down facility also. So next one is the superheater. Here this is a superheater. Once the boiler steam is generated, it is getting further superheated before going to the turbine. The superheater, the steam superheater is a coil type heat exchanger which is used to superheat the steam above its saturation temperature as per the requirement. It is located at a higher temperature gas flow bath. It increases the steam turbine efficiency and minimizes the corrosion of the turbine blades. So this is the superheater. In another one heat exchanger, we have that boiler evaporator tubes. See, the evaporator tube is connected from the bottom. There is a one header and a drum. It is a downcomer and up riser tubes connected like this. This is the evaporator tubes. So these evaporator tubes are very useful to circulate steam and water mixer between the steam drum and the downcomer header with absorbing heat from the flue gases. It increases the heating surface of the boiler. By means of circulating water between this down header and the boiler drum, this water getting evaporated further and further to assist the further evaporation of your steam. So that is the function of your boiler evaporator. The final one is that economizer, which is situated extreme end of your flue gas bath. So it is useful to heat the feed water coming out from the high pressure feed water pump nearly to the saturation temperature with respect to the boiler pressure by utilizing the heat transfer from the hot flue gases. So this preheater already we discussed in the feed water system. It is located near to the stack extreme end of your flue gas bath. It is useful to heat the feed water system before going to the boiler. And high steaming rate and boiler efficiency is getting improved because of we are preheating the feed water feeding to the boiler drum. So when you are talking about the boiler associate elements, this is a boiler drum, superheater, evaporator and economizer. These are the main important element inside the boiler. So that is the associated elements. When you are coming to the feed water system, there is a feed water which is taking from the condensate system is pumping back to the boiler with the help of multi-stage high pressure feed water pump. The picture we see, this is a high pressure feed water pump. This is taking water from the deaerator. We used to call deaerator. This deaerator is a having the mechanical deaeration function as well as the deaerator storage tank. This deaerator getting water from the condensate system, where the condensate water collecting from the hot well, that water is coming to this deaerator. From this deaerator, the deaeration takes place. What is means deaerator? So the deaerator is useful to remove the oxygen and CO2 non-condensable gases from the boiler feed water. Because why we have to remove the oxygen and non-condensable gases means these are the gases making the corrosive nature to the feed water system and corroding that boiler equipments and elements. In order to avoid corrosive effect, so we have to entirely remove the oxygen and non-condensable gases from the boiler with the help of deaeration in the deaerator. So the mechanical deaeration in the deaerator restricts the carryover of the oxygen content to the boiler so that it is useful to protect the boiler and its tubes from the corrosion. So the deaerator, once this deaerated water means the clean oxygen free water is getting collected in the deaerator storage tank. From this storage tank, this water is taken to the suction of the boiler feed pump. This boiler feed pump pumping at a high pressure water to the boiler through the economizer. So this boiler feed pump, what is the boiler feed pump? Boiler feed pump is a essential component of the feed circuit. It supplies the required quantity of high pressure feed water to the boiler drum by taking suction from the deaerator storage tank. So it gets condensed water from the condenser hot well. So where the water is coming from deaerator, it is from the condenser. So the boiler feed water pump is normally the centrifugal pump is a multi-stage type. So these are the high pressure feed water pump. So we will discuss that remaining equipments in the forthcoming session. So far we have discussed that different equipments which is involved in the thermal power plant. So we will continue our lecture for further see the different further level of equipments in this thermal plant.